Hi students, welcome to this section where we deal with percentages. Let's get started with the basics of percentages. Now, what do we mean with percent? You can see that it's per cent, right? And that means for every 100 because cent stands for 100. Alright, now let's take an example to understand percentages in a good manner. For example, let's have Teresa who's writing an exam and she got 20 out of 40 marks. Alright, now that means in 40 marks, she got 20, right? So that's what we've written over here. Now, if the exam was out of 1 and if she had maintained her performance, she would have got 20 by 40, right? How is that so? To make this 40 into 1, you need to divide it by 40, right? So 40 by 40 gives you 1. Similarly, when you divide this side by 40, you need to divide this side also by 40. So in that way, you can see that if the exam was out of 1, she would have got 20 by 40 marks, right? Now, if the exam was in 100 marks, she would have got 20 by 40 into 100, which is equal to 50, right? How is that so? Over here, we know that if the exam was out of 1, she would have got 20 by 40 marks. And remember, 20 by 40 simplifies to 1 by 2 or 0.5, right? So in 1, she would have got 0.5. Now, if the exam is in 100, so you need to multiply this with 100, right? So when you multiply this side with 100, you need to multiply this side also with 100. That's how you get 20 by 40 into 100 over here, which is equal to 50. So this means that 20 divided by 40, which is what we have over here, is equal to 50 divided by 100, right? So that's what we have established over here. Now, therefore, 20 by 40 is what we call as 50 percentage, right? And that's this 50 over here. Because remember, percent is for every 100. So that means if somebody gets 20 marks out of 40 marks, for every 100 marks, that person would have got 50 marks, and hence 20 by 40 is 50 percentages. Now, a quick side note, remember this process that we followed over here is also called the unitary method. Now, think that this is in a country where you want to buy mangoes and mangoes are quite costly. Now, for example, let 40 mangoes, let me write that over here. So this is mangoes. Let 40 mangoes cost $20, right? In that case, one mango would cost 20 by $40 and 100 mangoes would cost 20 by 40 into 100, which is $50. So it's the same process that we have followed over here to understand percentages also. So that was a quick side note. Let's get back to percentages. Now, let's try to understand a few more interesting terminology or phrases that you will see in percentages related questions. Now, first let's start to find out what we mean with X percentage of Y. Let's take an example. Say you want to find 25 percentage of 400. Alright, so we start with this 25 over here, and 25 percentage means 25 by 100, right? Now, the next term over here is of. So of, we replace that with the multiplication, and then we write the 400 over here. So 25 percentage of 400 is equal to 25 by 100 into 400, and that simplifies to 100. So 25 percentage of 400 is equal to 100. Alright, now the next term that we want to analyze is what percentage of X is Y. Let's take an example. What percentage of 400 is 100? Alright, what does it mean? So we have the 100 over here, alright, and this is out of 400, right? Because it's of 400. So it's out of 400, you have 100. So that's 100 divided by 400. Now, this has to be expressed as a fraction where the denominator is 100. In that case, you can call the numerator as the percentage. Alright, so 100 by 400 can also be written as 25 by 100, right? So you just need to cancel 4 both from the numerator and denominator. So 100 by 400 is equal to 25 by 100. Now this fraction has 100 as its denominator. So this is 25 percentage, right? This over here is 25 percentage. Now therefore 100 is 25 percentage of 400. Alright. Now the last term that we want to see in this video is converting a fraction into a percentage. For example, let's try to convert 2 by 5 into a percentage. Alright. Now, what does this mean? This means writing 2 by 5 as X by 100, right? So over here, you just need to find this X. You can either think of it as taking the 100 to the left hand side. So division becomes multiplication. and you get 2 by 5 into 100 is equal to x, or you can think of it as multiplying the left hand side and the right hand side with 100, right? So you get x is equal to 2 by 5 into 100, which is equal to 40, right? Therefore 2 by 5 is equal to 40%. All right, let's quickly revise what we learned. We saw that percentage stands for every 100, right? And we have seen how to convert a fraction to a percentage. That's what we've done over here. And we have seen the expressions x percentage of y, for example 25% of 400, and we have seen the expression what percentage of x is y. Over here we had what percentage of 400 is 100. In this video, let's try to understand percentage change. Let's get started. Over here we have Mr. Hen. He has $250 and 1 year passes by, he does some business and he gets $750 at the end of 1 year. Alright, now let's try to understand two terms. What's the absolute change in terms of the money he has and what is the percentage change? Let's get started with the absolute change. The absolute change of the money that Mr. Hen has is 750 minus 250, that's equal to $500. So over here 750 is the final value and 250 is the initial value. Okay, and what is the percentage change in the money that Mr. Hen has? So that would be 500 divided by 250 into 100. What's the 500 over here? This 500 is the absolute change or the change. And what is the 250 over here? The 250 over here is the initial amount that Mr. Hen had. So the percentage change is defined as the change divided by the initial amount into 100. Alright, now that's equal to 200%, right? 500 by 250 is equal to 2 and 2 into 100 gives you 200%. So from this year to this year, Mr. Hen experienced a 200% change in the money that he had. Alright, let's keep this aside and try to understand what we mean with this. Alright, so what's the meaning of this 200% change? Over here, he has finally 750 and he started off with 250, right? You can see that 750 is equal to 250 plus 200% of 250. Or you can say that 750 minus 250, which is the change, the absolute change, that's equal to 200% of the initial amount with which he started off. And that is what we mean with percentage change. So the change is what percentage of the initial amount. The change is 500 and that's 200% of the initial amount. And hence the percentage change in the money that Mr. Hen has is 200%. And remember, the way we found 200% is change divided by the initial amount into 100. Now the most common mistake that students make is they get confused whether to have the initial amount in the denominator or the final amount. Now we'll see in questions, with some practice you will be able to avoid this common mistake. But remember, when you want to find the percentage change, the denominator over here is always the initial amount. Let's do this question. In 2000, the percentage marks needed to pass an exam was 40%. Because of the increase in competition, today the percentage marks needed for passing is 50%. Alright, find both the percentage point change and the percentage change of pass percentage. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now you can see that the pass percentage required changed from 40% to 50%. Now let's start and first find the percentage point change. So that's the absolute change, which is equal to 50 minus 40. That's final value minus initial value, which is equal to 10. So the percentage point change is equal to 10. Alright, now let's find the percentage change. Now don't get confused that over here also you have percentage and over here also you have percentage, right? Now this percentage over here would not have made any difference even if it's rupees or whatever. You could have that the application fee was 40 rupees and that changed to 50 rupees. In that case also the rupee point change would be 50 minus 40, which is equal to 10, right? Alright, now over here you have 10% change in the percentage. So that would be change by initial value. And remember over here the change is 10 percentage points. So that's 10 over here divided by the initial value. What was the initial pass percentage requirement? Was it 40 or 50? It was 40, right? We started off 40 and it changed to 50. So the initial value is 40, right? So remember, this is very important to correctly identify the initial value. So that's 10 divided by 40 and into 100 to get a percentage, right? So that's equal to 25 percentage, and that gives you the answer as option A. You have 10 percentage points changed, and the change in the pass percentage in terms of percentage is 25 percentage. The next topic that we want to discuss is increasing or decreasing by a given percentage. To understand this, let's take two examples. I want to increase 20 by 25 percentage and I want to decrease 20 by 25 percentage. Let's get started with this one over here. So what does this mean actually? This means that you want to increase 20 by 25 percentage of 20. That's what we mean when we say that increase 20 by 25%. And that would be 20 plus 25 by 100 into 20, right? Because this part over here is 25 percentage of 20. And this simplifies to 5. So that's 20 plus 5, which is equal to 25. Now you can see that you could get this also by doing 1.25 into 20. That's also 25. So how do you get this 1.25? Over here in this expression, take out 20, which is common among these two parts. And over here you have 1 and plus 25 by 100. Right? So this part over here could be written as 20 into 1 plus 25 by 100, and 25 by 100 is 0.25. So 1 plus 0.25 gives you 1.25 into 20. That's this 20 over here. So increasing 20 by 25%, you can also do it like this. That's 1.25 into 20, which is equal to 25, right? Because 1 into 20 is 20 and 0.25 into 20 is the same as 1 by 4 into 20, which is equal to 5. So 20 plus 5 gives you 25. So this is the faster way in which you can do these type of operations. Now let's go ahead to this part where we want to decrease 20 by 25%. So that means you want to decrease 20 by 25 percentage of 20, which is what you have over here, right? So that's equal to 20 minus 25 by 100 into 20. This is equal to 5. So 20 minus 5 gives you 15. Now you can do this also as 0.75 into 20, which gives you 15. Now how do you get this 0.75? It's the same process that we followed over here. Take out 20 from this expression over here as common. So over here you're left with 1. 20 by 20 is 1 minus, and over here you took this 20 out, so you're left with 25 by 100. And 25 by 100 is equal to 0.25. So 1 minus 0.25 gives you 0.75. So 0.75 into 20 gives you 15. Alright, so we have seen that if you want to decrease 20 by 25%, you just need to multiply 20 with 0.75, and that is 1 minus 25%, or 1 minus 25 by 100. Alright, now let's do some more practice to solidify our learning in this video. Say you want to increase 75 by 30%. So we know one way, which is the longer way. In this way you can always find it, but let's practice this method over here. So you want to increase 75 by 30%, right? So how do you do that? So that would be 1.3 into 75, right? So how do you get 1.3? That's 1 plus 30%, or 1 plus 30 by 100, which is 0.3. Now say you want to decrease 82 by 60%. So what would that be equal to? That would be 0.4 into 82, right? How do you get this 0.4? That's 1 minus 60%, or 1 minus 0.6, which is 0.4, right? And say you want to increase 120 by 10%. So that would be 1.1 into 120. How do you get this 1.1? That's 1 plus 10%. 10% is the same as 0.1. So 1 plus 0.1 gives you 1.1. Let's do this question. Bob and Andy are best friends. They always study together. Clara and Amy are also best friends, and they too study together. Bob and Andy together scored 10% more marks than Clara and Amy together. Bob got 80 marks. Clara got 75 marks. how much percentage more or less did Amy score than Andy if Andy scored 85 marks? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now over here we have Bob and Andy, they are best friends, and we have Clara and Amy, they are also best friends. Now it's given that Bob scored 80 and Andy scored 85 marks, right? So that's a total of 165 over here. Now let's take Amy's marks as X, and it's given that Clara scored 75 marks. So that's 75 and X. So the total is 75 plus X. Alright. Now it's given that Bob and Andy scored 10% more than Clara and Amy. So that means 165, which is what we have over here, is 110% or 1 plus 10 by 100 of 75 plus X. And we have seen that you can write this directly as 1.1 into 75 plus X. Now let's solve for X. We get 75 plus X is 150, or you get that X is equal to 150 minus 75, that's equal to 75 over here. Now in the question we have to find Amy's score is how much percentage more or less than Andy's score, right? So you start from Andy's score. So we have 85 as the score of Andy and 75 as the score of Amy, right? Because we have found that X is equal to 75, and the percentage change over here is 85 minus 75, which is the absolute change, divided by the starting point. And remember over here we are comparing it compared to Andy's score. That's why the denominator over here is 85 and not 75, and that's the most common mistake that students make. So make sure that you have 85 in the denominator over here. So that is 10 divided by 85 into 100, and on solving you will get this as 11.8%, which is option B. In this video, let's try to understand constant product type problems. Alright, so you have a family that is next to you and they love milk. Alright, so they love milk, and say the price of a packet of milk goes up by X%. Now the question is, by how much should that family reduce the consumption of milk so that the expenditure remains constant? So this is a common type of question that you will see. Now over here you can note that the price increased by X%, right? And therefore the consumption has to be decreased by some percentage. Why is that so? Because the expenditure is equal to the price into consumption, right? For example, if the price of a packet of milk is $1, and if they used to consume 5 packets, that's a total of $5. Now if the price goes up to $2, so they can only consume 2.5 packets, right? So that 2 into 2.5 is also 5, 1 into 5 is also 5. Alright, so that's what we mean with this type of questions. Now to solve this type of questions, let's discuss in this video a shortcut as well as the conventional method. Alright, let's keep this aside and we start with the shortcut. Now over here you can see that there are two parameters, right? For example, expenditure is constant, price is one parameter, consumption is one parameter. So P1 stands for parameter 1. Similarly, P2 stands for parameter 2. Now if one parameter increases by 1 by X, then we can easily find by how much the other parameter has to decrease. Now let's take an example and parallelly go ahead with the method. For example, in this case, let's say that the price increased by 20%. Now you will see that over here you have a percentage and this is a fraction, right? So we need to convert this percentage into a fraction, which can be done very quickly. Now let's see how this can be done. So 20% is nothing but 20 by 100, right? So you can see that that's the same as 1 by 5, right? You can either think of it as cutting 20 both from the numerator and denominator and you get 1 by 5, or if it's not divisible like this, in some cases you might have 2 by 13, etc., right? So that can be written as 1 by 100 by 20. So you took this 20 to the denominator, so this becomes 1 by 100 by 20. Remember, 1 by A by B is equal to B by A. So that's what we have used over here. And that's equal to 1 by 100 by 20. 100 by 20 is 5. So again, you get 1 by 5. All right. Now, if you can do this very quickly and with practice, you'll be easily able to do that. So the price increased by 20%. Now we've converted 20% into 1 by 5. In that case, the parameter 2, or in this case, that's consumption, right? Consumption is the parameter 2 in this example which we are dealing with. That parameter has to be decreased by 1 by x plus 1. So if there is an increase of 20%, which is 1 by 5, you need to decrease consumption by 1 by 6, and 1 by 6 is the same as 16.67%. You can convert 1 by 6 into percentage, you'll get 16.67%. So if the price increased by 20%, the consumption has to be reduced by 16.67%. Remember, how do you do this conversion? That 1 by 6 is 16.67%. That's using 1 by 6 is equal to x by 100, and you just need to find x, right? So x will be 1 by 6 into 100, and that will be 16.67%. All right. Now, if the parameter 1 decreased by 1 by y, then the other parameter would be increasing by 1 by y minus 1. So you don't need to study these separately. It's one and the same. You can see that it's one and the same. Now from here to here, you just, if you put y is equal to x plus 1, you will get x is equal to y minus 1, and you will get this part over here. So I would recommend that you just remember one of them. And one more interesting thing to remember is, remember, wherever is the decrease, it has the higher denominator. So over here, the increase is 1 by x and the decrease is 1 by x plus 1. Over here also, the decrease is 1 by y, the increase is 1 by y minus 1. So you can see that the decrease part is the greater value, right? In both the cases, you just need to remember one of them, and accordingly you can apply it in problems. We'll see it in examples. All right. Now let's keep this aside, and let's also take this case soon. But before that, I'll just want to have a quick side note. Now we have seen that if the price increases by 20%, we have seen that the consumption has to decrease by 16.67%. So we have seen one method to find this using this approach, right? You could also take an example and find the same thing. For example, assume that the expenditure was 100, right? So the constant product is 100. Now 100, if you increase it by 20%, that's 120, right? Now by how much should you reduce this so that you get back to 100? So that's the same thing, right? So the change, the percentage change, remember, is always change by initial value. The change is from 100 to 120, right? So that's 20. 120 minus 100 gives you 20. That's the change. So 20 by the initial value. So you're going in this direction, right? You're going in this direction. So the initial value is 120. So 120, 20 by 120 also gives you 1 by 6, which is the same value that we got over here. That's also 16.67. All right. Now, let's get back. And we have seen the case where the price increased. And I've also mentioned that it's the same as decrease. But just for thorough understanding, let's take an example where the price dropped by 20%. So then that means that you can increase the consumption, right? Now let's use this method over here first. So 20%, we have seen that it's 1 by 5. Now if there is a decrease in 1 by 5, you need to have an increase of 1 by 4, right? So over here, remember, wherever is the decrease, the denominator will be the highest. So because there is an increase and I have 5 over here, so I have to put a lower denominator. So that's 5 minus 1, which is 4. So if there is a decrease of by 1 by 5, then there can be an increase by 1 by 4, and 1 by 4 is equal to 25%. So if the price dropped by 20%, you can increase consumption by 25%. Now you can do the same thing taking an example also. Let's take that also over here. Initially, let's assume that the expenditure was 100. Now if there is a decrease in 20%, right? So that's 80, right? So 20% of 100 is 20. 100 minus 20 gives you 80. Now by how much should you increase 80 so that you get back to 100? So that percentage change is change by initial value. you're going in this direction, right? So the initial value is 80. So what's the change? It's 100 minus 80, which is 20, and the initial value is 80. So 20 by 80, which is equal to 1 by 4, which is equal to 25%, and that's the same thing that we got over here. All right, now we have seen this over here in the case of consumption type of problems where the constant product was the expenditure, right? Over here we have expenditure is equal to price into consumption. Now this same method can be used also in different types of problems. For example, there could be a case where time into speed is constant and time into speed is distance, or efficiency into time, which is equal to work, that's constant, right? In these cases also the same method can be used, and we will see more of these in their respective sections in this course. All right, now we have covered the shortcut, and we have also covered the logical way of approaching it, where you assume 100 and then you make the change and then you try to get back to 100. We have seen both these approaches. Now let's also discuss the conventional method quickly, and I recommend that you should not be using the conventional method because the initial methods that we discussed are much faster. But just for a deeper understanding, let's quickly also think of the conventional method. All right, so over here expenditure is equal to price into consumption, right? Now I can say that the price increased by X%, that's what's given over here, right? Therefore the new price will be 1 plus X by 100 into P, and it's also mentioned that the expenditure is constant. So I will use E itself for the expenditure in the second case. So I can write that expenditure is equal to 1 plus X by 100 into P, right? This is the price that has been increased by X percentage into the new consumption, which is C2, right? All right, so this I can rewrite it as C is equal to 1 plus X by 100 into C2, because I take this P to the left hand side and I get E by P over here, and E by P is equal to C from this equation over here, right? E by P is equal to C. So we substitute that over here to get C is equal to 1 plus X by 100 into C2, and therefore you can say that C2 is equal to C by 1 plus X by 100, and you know X. For example, it could be 20% or it could be 25%, and using that you can find the new consumption, that is C2, and with that also you can find it. But we have already discussed some interesting methods with which we can find this much faster, and we will be applying it in future practice problems. Hi students, in previous videos we have seen various cases where we had to convert a fraction into a percentage, right? Now in this video let's discuss some important fractions and their equivalent percentages, and it will be helpful to commit these to memory because they help to increase your calculation speed as well. All right, let's get started. Now few of the important conversions between fraction and percentage would be 1 by 2 is 50%, 1 by 3 is 33.33%, 1 by 4 is 25%, 1 by 5 is 20%, and a few more would be 1 by 6, that's 16.67%, 1 by 7 14.28%, 1 by 8 is 12.5%, and 1 by 9 is 11.1%. Now it's good to know the reciprocals up to 20, but we'll see that later. Now let's keep it up to 9 for now. Now 1 by 2 is 50%. Remember, what does this mean? This means that 1 by 2 is equal to 50 by 100. Or say 1 by 6 is 16.67%. What does this mean? So that means 1 by 6 can also be written as 16.67 by 100. Now this is an approximation. This keeps going as 16.6666 etc. And we approximate it as 16.67. Alright. Now if you know these, you can easily find, for example, 2 by 3. If you know 1 by 3 as 33.33%, 2 by 3 will be 2 times 33.33, right? So that would be 66.66%. Similarly, if you know 1 by 7 as 14.28%, then 2 by 7 can easily be found as 28.56%, which is 14.28 into 2, right? Now if you know 1 by 9 is equal to 11.1%, then you can easily find that 2 by 9 would be 22%, or 22.2. We can approximate it as 22%. Now one more important thing which you can note is that if you know these very well, you can even do some multiplications in a very fast manner. Let me quickly demonstrate that to you. For example, if you're trying to find out 28 into 14.28, and if you know that 14.28 is the percentage equivalent of 1 by 7, right? So then you can replace this sum as 28 into 100 by 7, right? Because you know that 14.28 by 100 is equal to 1 by 7. So 14.28 would be 100 by 7. So I am replacing 14.28 with 100 by 7. So this becomes 28 into 100 by 7, and 28 and 7 have common factor of 7. So we cut that out and we get that this is equal to 4 into 100, which is equal to 400. So 28 into 14.28 is approximately 400. And this is the fastest way in which you can do a lot of multiplications. And that's the added benefit of knowing the percentage equivalence of some important fractions. Let's do this question. Benji loves to drive his bike. He noticed that the petrol rates have gone up by 12.5%. By how much should he reduce his bike ride kilometers to keep his monthly riding expenditure constant? He used to travel 180 kilometers every month, and his bike has a mileage of 15 kilometers per liter of petrol. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now over here, it's mentioned that the price has increased by 12.5%, and 12.5% is the same as 1 by 8, right? Now, if the price increased by 1 by 8, to keep the expenditure constant, the consumption has to be reduced by 1 by 9, right? 1 by 9 is 1 by 8 plus 1. That's how you get 1 by 9, right? Now, alright. Now, therefore, the kilometers also will reduce by 1 by 9, right? Now, how much is 1 by 9 of 180? That's 180 into 1 by 9. That gives you 20 kilometers. So, he can travel only 20 kilometers less, or he can travel 160 kilometers. Now, the question says, by how much should he reduce his bike ride kilometers? So, he should reduce his bike ride kilometers by 20 kilometers, right? And you can also note over here that the consumption is directly proportional to kilometers. So if he is consuming more petrol, he'll be able to ride more kilometers. Or if the consumption is reduced by 1 by 9, then the number of kilometers that he could travel also will be reduced by 1 by 9 of the initial number of kilometers he used to travel. And that's how we get the answer as 180 into 1 by 9, which is equal to 20 kilometers. Let's do this question. Grace is seeing the plan of her house. She tells the architect to increase the length of a rectangular room by 20% without increasing the area of the room. By what percentage must he reduce the breadth of the room? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now over here you can see that the area has to be maintained constant, right? So it's mentioned without increasing the area of the room. Now we know that in the case of a rectangle, the area is length into breadth. So length into breadth has to be maintained as a constant. Now she also tells the architect to increase the length by 20%. So the length has to be increased by 20%, and 20% is the same as 1 by 5. So there is an increase of 1 by 5. Now to maintain the area constant, the breadth has to be decreased by 1 by 6, right? So we have already seen that, and 1 by 6 is equal to 16.67%. Therefore, the correct answer to this question is option B, that's 16.67%. In this video, let's discuss income comparison type problems. Now, for this, let me take an example. I have Miss B over here and Mr. Hen over here. Now, say it's given that B's income is X percentage more than H's income. Alright. Now, say you want to find out then H's income is how much percentage less than B's income. So these type of questions also can be done in the same manner that we discussed before. Now let me give you the method first, and then we'll try to understand why it is so. Over here you have an increase by X percentage. Now if this is an increase by 1 by A, then the decrease would be by 1 by A plus 1. Let's try to understand this. Say it's given over here that B's income is 20% more than H's income. Let me take this as 20%. In that case, what does it mean? It means that H plus 20% of H, right? And we know that 20% is 1 by 5. So I can write it as either 20 by 100 h, or I can write it as h plus 1 by 5 into h. That is equal to b. That's what we mean when we say this, right? Now, if this is true, I can simplify this as 6 by 5 h is equal to b, or I can say that h is equal to 5 by 6 b, or this is the same as 1 minus 1 by 6 b, right? So if there is an increase by 1 by 5, there has to be a decrease by 1 by 6. Or if b's income is 20% more than h's income will be 1 by 6, which is 16.67% less than b's income. All right, now we have discussed this method over here, which helps us to do it very fast, and we have over here discussed the logic behind this method. Now let's also think of it in one more angle, because it always helps to approach a problem in multiple dimensions. All right, so let's assume that the salary of h is equal to 100. All right, now if the salary of h is equal to 100, then if you want to find b's income, you need to increase that by 20%, right? That's what we've assumed over here, and you get 120. Now if you want to know by how much h's income is less than b's income, that means you have to go from 120 to 100, right? So how much percentage should you reduce to go from 120 to 100? So that would be change by initial value, and when you're going back like this, you are starting from 120, right? So the initial value, which is the denominator, is 120, and change is 120 minus 100, which is 20. Therefore this percentage change will be 20 by 120, which is equal to 1 by 6, or 16.67%, which is the same thing that we have got over here. All right, now let me keep this aside. Now just for a complete understanding, the same is applicable in the case where you start with a decrease. Over here we started with an increase. You could also start with a decrease. B's income is x percentage lesser than h. H's income is how much percentage more than b. The same would apply over here. If this is 1 by a, then this would be 1 by a minus 1. Remember, wherever is the decrease, the denominator will be greater. So for example, in this case, there was an increase by 1 by 5, there would be a decrease by 1 by 6. If there is a decrease by 1 by 5, there will be an increase by 1 by 4. In both the cases, wherever there is the decrease, you have the higher denominator, right? All right. Let's do this question. Bina's salary is 30% more than the salary of Anne. How much percentage lesser is Anne's salary than Bina's salary? All right, pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Let's do it together. Now let's quickly discuss two methods to solve this. The first method is the shortcut that we discussed. Now 30% is the same as 1 by 10 by 3, right? Why is that so? 30% is nothing but 30 by 100. So you cancel out 1 0 and you take this 3 down. So you get this as 1 by 10 by 3, because a by b is equal to 1 by b by a. That's what we've used over here. All right. Now over here you can see that this 1 by 10 by 3, let's take that as 1 by x. Now we just need to find 1 by x plus 1, right? Because this is an increase. This is an increase by 30%. So the decrease would have the higher denominator. We just need to find 1 by x plus 1, right? Over here you have x as 10 by 3. So x plus 1 will be 10 by 3 plus 1. So you do 1 by 10 by 3 plus 1, which is equal to 1 by 13 by 3 or 3 by 13. So 3 by 13, on solving you'll get that as 23%. So it means Anne's salary is 23% lesser than Bina's salary. Now let's also take the logical approach. Say Anne's salary is 100 and Bina's salary would be 30% more. That's 130, right? Now if you want to go from 130 to 100 like this over here, then there is the absolute change of 30, and the initial value in this case will be 130. So the change is 30 by 130. The percentage change would be 3 by 13, which is the same as 23%. That is answer option D. Let's do this question. After getting 2 consecutive salary hikes, Don's salary increased by 32%. Alright. By how much percentage was the first hike if the second hike was half as much in percentage as the first hike? Alright. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now in this case, Don is getting 2 consecutive salary hikes, right? So he's going from X to X1 to X2, and it's mentioned that the second hike is half as much as the first hike. Alright, now in this question, we'll discuss 2 methods with which you can solve this. The first method is using the options, which is the best method to solve this question. Now let's assume that the initial salary was 100, and then we'll check the options. Now if the initial salary was 100, after getting the 2 hikes, he should go to 132, right? Because the net hike is 32%. So 100 into 1.32 gives you 132, or you can think of it as 100 plus 32 by 100 into 100. In either case, you go to 132, right? Alright, now let's check the options. Option A says that the first hike is 10%, and in that case, the second hike would be 5%. So you start with 100, you increase it by 10%. 10% of 100 is 10. So 100 plus 10 gives you 110, right? And from 110, you increase it by 5%. That gets you to 115.5, because 5% of 110 is 5.5. And that is not equal to 132. Therefore, answer option A is not correct. What about option B? You start with 100, you increase it by 20%, right? So you get to 120. 20% of 100 is 20, so you get to 120. Now from 120, you increase it by 10%, because over here you have 20, so half of 20 is 10. So you increase 120 by 10%, so that's 120 plus 12, which is 132, which is what we have to get, because his net increase is 32%, and hence the correct answer option is option B. Alright, now let me also tell you one more interesting method in this type of cases where you have a consecutive percentage increase. Now if the first increase is A percentage, right? So you go from X to Y, and that's an increase of A%, and you go from Y to Z, that's an increase of B%. In this case, the net increase will be A plus B plus AB by 100. Now let's try to apply this over here. If I put one as 20 and the other as 10, what would be the net increase? It's 10 because it's half of 20, right? So the net increase would be 20 plus 10 plus 20 into 10, which is 200 divided by 100. That gives you 20 plus 10 plus 2, which is equal to 32. Therefore, also answer option B is the correct answer.